The Joint Air-to-Surface Standoff Missile JASSM, designated AGM-158, is a long-range, precision-guided cruise missile developed by Lockheed Martin for the United States Air Force and Allied forces. It is designed to strike high-value, heavily defended, fixed or relocatable targets from significant distances without exposing the launch aircraft to hostile air defense systems. The JASSM represents a strategic leap in air-to-ground weapon capability due to its stealthy profile, extended range, autonomous guidance system, and hardened warhead, making it suitable for use in high-threat environments where traditional strike munitions would struggle to penetrate. The missile's aerodynamic design features a low observable airframe with a composite body and flush-mounted inlet, allowing it to evade radar detection during flight. Its capability to fly autonomously over long distances using GPS, INS navigation, mission planning software, and an imaging infrared seeker in the terminal phase gives it impressive accuracy against critical targets including enemy air defenses, command centers, bunkers, bridges, and industrial complexes. The cost of a single JASSM missile varies depending on the variant and production batch. The baseline AGM-158A model, which has been in service since the early 2000s, typically costs around $800,000 to $1 million per unit. The extended range variant, AGM-158B JASSM extended range, is more expensive, with prices generally ranging from $1.2 million to $1.5 million per missile, depending on procurement quantity and fiscal year. This version incorporates a more fuel-efficient turbofan engine and extra internal fuel, enabling it to nearly triple the range of the original model. The newest variant, the AGM-158D JASSM XR Extreme Range, which is still in development or early production stages as of the mid-2020s, is expected to cost significantly more, potentially upwards of $2 million or more per missile, due to its longer range, advanced datalink, and enhanced survivability features. While expensive compared to traditional munitions, the cost is justified by the missile's ability to strike high-value targets from standoff distances with minimal risk to personnel or platforms. The range of the JASSM varies depending on the model. The original AGM-158A has an approximate range of 370 kilometers, about 230 miles, which is sufficient to keep strike aircraft out of the engagement zone of many surface-to-air missile systems. The JASSM, by contrast, has a range of approximately 925 kilometers, 575 miles, achieved through the addition of a Williams F107WR105 turbofan engine and increased internal fuel capacity. The forthcoming JASSM XR will reportedly push the range envelope beyond 1,900 kilometers, over 1,200 miles, dramatically expanding strategic options for deep strike missions without requiring aerial refueling or forward base operations. The missile flies a low-altitude, terrain-following trajectory to evade detection and can be programmed to approach from specific angles or to strike at precise coordinates. The long range ensures that launch platforms, whether bombers like the B-52 or B-1B, or fighter aircraft such as the F-15E, F-16, or F-35, can strike from outside even the most sophisticated integrated air defense systems. The JASSM uses a highly survivable design, employing a stealthy, low-radar cross-section airframe and advanced electronic countermeasures to penetrate contested airspace. Its guidance system includes an inertial navigation system, INS, coupled with a GPS receiver, allowing it to autonomously navigate to the target with great precision. In the terminal phase of flight, the missile uses an imaging infrared seeker and a preloaded target signature to conduct autonomous target recognition and ensure final impact accuracy. This dual-mode guidance minimizes the likelihood of errors from GPS jamming or environmental interference and ensures effectiveness against well-camouflaged or GPS-denied targets. The JASSM carries a 450 kg, 1,000-pound WDU-42B penetrator warhead encased in a hardened shell, enabling it to destroy reinforced structures such as bunkers, hangars, and fortified buildings. The missile is capable of penetrating multiple layers of concrete or earth before detonation, making it ideal for eliminating deeply buried or protected threats. Testing and evaluation of the JASSM family has been extensive. Early versions faced development challenges during flight trials in the early 2000s, including reliability issues with sensors and seeker software. However, these were addressed through iterative improvements and hardware upgrades. Full-rate production began after several successful operational tests, which included live-fire trials against both stationary and moving targets in various weather conditions and terrain types. More recent testing of the JASSM and experimental models has included launch validations from multiple aircraft, stress testing in electronic warfare environments, and accuracy trials in GPS-degraded settings. The JASSM's performance during red flag exercises and other joint training missions has reinforced its value in multi-domain operations. The weapon has also been tested in maritime roles, with modified software enabling it to hit naval targets, broadening its mission applicability. Operationally, the JASSM has been fielded aboard U.S. Air Force platforms such as the B-1B Lancer, B-2 Spirit, B-52 Stratofortress, F-15E Strike Eagle, F-16 Fighting Falcon, and F-35 Lightning II. International allies including Australia, Finland, Poland, and the United Kingdom have also procured or are integrating JASSM missiles into their air forces, indicating broad trust in its capabilities. The JASSM is particularly valued for bomber fleets like the B-1B, which can carry up to 24 missiles internally, giving them the capability to perform massed standoff strikes against a wide array of strategic targets. The missile is designed for plug-and-play compatibility with multiple aircraft types via standardized interfaces, allowing seamless integration with targeting pods, mission planning software, and digital fire control systems. In operational scenarios, the JASSM provides a critical advantage in first strike and preemptive missions. Its range allows planners to target enemy airfields, surface-to-air missile batteries, command centers, infrastructure, and logistical nodes before friendly aircraft enter contested zones. In this way, it plays a role in air superiority, enabling follow-on forces to operate with reduced risk. Its low-altitude flight profile and infrared seeker make it especially effective against hardened or camouflaged targets, including mobile missile launchers and relocatable radar arrays. When integrated into joint operations, JASSM strikes can be synchronized with electronic warfare efforts, cyber attacks, or kinetic bombardments from other systems, maximizing battlefield effect and compressing enemy reaction time. In terms of strategic value, the JASSM contributes significantly to deterrence, providing conventional options for long-range precision strike without needing nuclear payloads. This gives the United States and its allies a credible means of responding to aggression without escalating to weapons of mass destruction. Furthermore, its stealthy characteristics and wide range of launch platforms complicate enemy air defense planning, as they must account for multiple threat vectors from vast distances. The ability to launch from U.S. territory, allied bases, or even carrier-based aircraft in the future extends operational flexibility and ensures power projection across regions like the Indo-Pacific, Middle East, and Eastern Europe. While the missile has not been used extensively in publicized combat operations, its presence serves as a constant factor in contingency planning. The sheer capability of JASSM, particularly the JASSM and XR variants, gives policymakers a powerful precision tool that is both flexible and survivable. As the global security environment evolves, with peer competitors developing advanced air defense systems, the need for long-range standoff munitions like the JASSM becomes even more critical. This ensures continued investment in upgrades, including networking features, increased data link capacity, and multi-mode seekers. The JASSM program represents a convergence of stealth, precision, survivability, and range. From concept to deployment, it reflects a clear shift toward survivable standoff firepower, enabling air forces to achieve operational goals without direct contact. Its cost, while significant, is justified by its capabilities, and the system's evolution into extreme range and maritime-capable variants ensures relevance through at least the 2040s. With multiple foreign military sales and a growing user base, the JASSM is positioned not only as a key component of U.S. deterrence but as a cornerstone of Allied strike capability worldwide.